In this video, we'll be looking at 3b, finding the length of the shorter sides. So the key idea here is that when we find the length of a side, we need to first substitute known values into Pythagoras' theorem. We also need to solve this equation to find the unknown value. So if you guys remember from last class, Pythagoras' theorem is given by c squared equals to a squared plus b squared. Remember, the length c is always the longest side opposite the right-angled triangle. The example we have here is this triangle here. So you've got a side length of A, another side length of 15, which we're going to assume that's B, and the longest side length has to be 25, because that is opposite the right angle, which is on the bottom right. So let's try and figure out the shorter length, A. So to work this out, we need to substitute what we know. So C is going to be 25, so this becomes 25 squared equals to A squared plus B squared. B squared, we're going to label this as 15. So what we have now is 625 equals to A squared plus 225. To get A by itself on one side, we need to move this 225 to the other side. So what we get is 625 minus 225, which gives us 400. And to get rid of the square, we just need to square root 400, which gives me an answer of 20 as A. Alright, pretty straightforward. Let's try an example ourselves. In each of the following, find the value of the pronumeral, round your answer in part B to 2 decimal places and give an exact answer to part C. So let's try A first. So once again, let's apply Pythagoras' theorem. I'm going to write it on the right hand side here, just so you have an idea. C squared equals to A squared plus B squared. So let's label our triangle. We're going to label the longest side length of 25 as C. This one will be A, so therefore 24 must be B. So let's fill in what we know. C squared is going to be 25 squared equals to A squared, which is going to be just A squared. And B squared is going to be 24 squared. So 25 squared is going to give me 625 equals to A squared plus 24 squared, which will give me 576. Move the 576 to the other side, and we get 625 minus 576 equals to A squared. 625 minus 576 will give me 49 equals to A squared. So we just need to find the square root of 49, which is 7. So that's how you find the length of the shorter side. Let's look at example B and give this one a go as well. So once again, 6.2, B and 12, we're going to label our hypotenuse first. So that's always opposite the right angle. That's C, that's going to be A, and that has to be B. So let's fill in these values. So C squared is going to be 12 squared equals to A squared plus B squared. A squared is 6.2 squared plus B squared we'll leave as is. So now we have 144 minus 6.2 squared, which would give me a value of 38.44 equals to B squared. 144 minus 38.44 will give me 105.56 equals to B squared. Find the square root of 105.56, and that will give you B. So if I put this on my calculator, that should be the same as B equaling to 10.27 if I round it to 2 decimal places. Let's try the last example, C. So for this one, we are given 7, and we are given a side length of X, and we are also given a side length of X. So let's label what we know. C must be the longest side length opposite the right angled triangle, so that's going to be here. X is A here, and B is also there. Okay, so C squared equals to A squared plus B squared. So 7 squared. So we have 7 squared equals to A squared plus B squared. We know that A squared is the same as B squared because they're both X, because these two lines represent the same length. So 7 squared equals to x squared plus x squared. So 7 squared equals to 2x squared. What we're left for now is 49 divided by 2 equals to x squared. And we just need to square root 49 over 2 to get x. And that should be the same as 7 over square root 2. That's your final answer. Alright, that's it for this one. Hopefully you learned something. I'll see you on the next one.